Good morning, Prof. Dr. Suhaimi. My name is Chua Yun Huang. Today I want to present my project, which is aircraft static stability and performance. First of all, my objective of the project is to determine the longitudinal static stability of the paper plane without the weight and with weight added. And we need to calculate the stick fixed neutral point of the paper plane and stream speed, power to the weight ratio, lift to drag ratio, and the power required of the paper plane. Next, first of all, we need to make our own paper plane. So I follow this dimension and I using Manila cut to build it out. And after that, after I build my paper plane, I need to calculate the aerodynamic center of the paper plane. So first of all, I need to calculate the taper ratio, aspect ratio, and mean aerodynamic torque. And why we need to calculate mean aerodynamic torque is because of the aerodynamic center of the paper plane is located at 25% of the mean aerodynamic torque. So from the picture below, the yellow color one is the mean aerodynamic torque. So going down, 12.75 mm is 25% of the MAC. So I can get my aerodynamic center is 22 mm from the nose of the paper plane. And next, how I calculate the center of gravity of the paper plane. And I using one of the pencil, I using the tip to stabilize my paper plane. So that point is my center of gravity of the paper plane. So the right hand side, which I get my center of gravity and aerodynamic center. And after that, I got try to do some flight tests using my paper plane, and this is one of the video. This video, it can clearly show that my paper plane is spinning and does not have the smooth gliding. From the flight test just now, I have redo again to do 10 times to get the mean value of the flight test. And height, I just fix it out, is 1 meter, and the distance and time I need to record throughout the experiment. And the speed, lift to drag ratio, lift coefficient, and drag coefficient, this all is I need to calculate by using formula. And the standard deviation, I check, this is one I check my result, is it consistent or not. So from here, I can see that my standard deviation all is less than 0.3. So I just assume all the experimental result is acceptable. After that, just now I got mentioned, I need to calculate the speed, lift to drag ratio, lift coefficient, and drag coefficient. So here is all the formula I'm using to calculate all the value. After that, I have to do the flight path versus time taken graph. So I get is the linear graph. So like this one. Yeah, so from 1 meter height throwing and it reached the ground is 1.26 seconds. This is the average mean. And I do a pitch angle versus time graph, which show that after I record the video, I got do a slow motion video. I got clearly see my paper plane, which has spin 6 rotation before it land on the ground. So this is a graph of the pitch angle of my paper plane. Next, after that, I need to check my paper plane, is it static stability or not. I need to calculate the longitudinal performance of my paper plane. I'm using the Cm alpha to calculate. Then from the flight mechanics textbook, it got mentioned that if aerodynamic center is behind of the center of gravity, I can get my Cm alpha is less than 0. But from the experiment I done, we show that Cm alpha is bigger than 0, which is 1.6 something. So I can conclude that my paper plane center of gravity is behind of the aerodynamic center. So just now I got one proven. From the calculation, I get the aerodynamic center and center of gravity. This is actual one is my center of gravity is behind of aerodynamic center. Next, I got add the weight on my paper plane. So where should I place my weight is I need to using this formula to get my weight. Okay, then why here I put 0.022 is because 0.022 is my aerodynamic center. So I need to add the weight, show that my center of gravity can in front of aerodynamic center. So I get is negative 0.11. Thus, for my experiment, I set my weight is 0.015 meter away from the leading edge. And after that, I got recalculate again my center of gravity, and it showed that my new center of gravity is 0.007. So here you can clearly see that my center of gravity is in front of aerodynamic center. So these two pictures which can clearly show that the improvement of my center of gravity. Next, this is after that I got do the flight test again with the paper plane with the weight added. And from this short video, we can clearly see that my paper plane which have a smooth gliding and does not have any spinning, and each is going in the straight way. So my paper plane is good. And here is my flight test. I got do 10 flight tests. I just calculate again like paper plane without any weight. The calculation all is the same, and I get the standard deviation also less than 0.025. So I assume my experimental result is acceptable because all the value is consistent. And next, I got do some calculation with the speed, which is using distance over time, and the lift to drag ratio, and lift coefficient and drag coefficient. So here is the flight path of my paper plane, and the top picture is show that my paper plane is without any weight added, and the below one is the paper plane with ballast one. So top one is show that my graph is a linear graph, and below one is like a parabolic graph. Next is the pitch angle. Left one is just now the paper plane without any weight added. This is like sine graph and does not have a smooth like a right one. So the right one is show that my paper plane is gliding smoothly and landing on the ground. And I just redo again my longitudinal performance of my paper plane, which show that my Cm alpha is negative 1.7 something, and this is because my center of gravity is behind of the aerodynamic center. And Cm alpha less than 0 also mean that my pitch angle is negative, which is the paper plane is pitched downward when it's landing. So it does not spinning when the process of the landing. So here is the stick fixed neutral point, and I got using the equation from the flight mechanics textbook. I just do the calculation to get my neutral point. Then here I get the one of the conclusion is my center of gravity is ahead of my neutral point. So my paper plane is have a positive stability and have a positive static margin. And after that, I got do some trim speed calculation for my paper plane. So here is my value I get from this equation is get from the flight mechanics textbook. After that, this is drag polar curve. I plot by using CD drag coefficient versus CL square lift coefficient square. So I get the drag polar equation from this graph. After that, I got calculate the power required and the power to the weight ratio of my paper plane. I get the value. Next, how I improve my paper plane is I apply the wing dihedral concept into my paper plane. So what is wing dihedral? Wing dihedral is the upward of angle of aircraft wings. Dihedral can improve the lateral stability of the aircraft by causing the lower wing to fly higher angle than the higher wing. So below picture it shows that dihedral wing is like going upward one compared to the flat. Yeah. So I just do a example to get the knowledge better. So dihedral from here, the left picture is show that the relative wind is flow from the right to the left to hit the aircraft. Then my aircraft have a slip direction toward the right. and the relative wind has imbibed against the wing, which caused the wing to tail up slightly. After that, the wing will create a lift force to like do a torque toward left. So the green direction here is the torque to push back our aircraft to the wing level. So our aircraft have a stable when it is trimmed. So when it is meet any wind gust or what, it can trim smoothly. So that's all for me. Thank you for all your times. Have a nice day. Thank you, Prof.